Have you ever looked at a giant mountain or even just a little stone you picked up and thought, what is this thing really made of? What's its story? Well, today, we're going to learn exactly how to read that story, a story that's written in the very ground we stand on.
Okay, so just take a look at this incredible view of the Peninsula Ranges down near San Diego. It's massive, right? You've got mountains, valleys, coastlines. It's super complex. But you know what? It all boils down to one simple thing: rock. The big question, though, is what is that rock and how in the world did it get here? That's exactly what we're going to dig into.
So, here's our game plan. We're going to start with the absolute basic building blocks. Then, we'll see how those blocks get put together to make three main families of rock. After that, we'll get into the planet's amazing recycling system, the rock cycle. And finally, we'll pull it all together so you can use this knowledge to read any landscape you see.
To understand the story of any rock, you have to start at the very beginning, with its most basic ingredients. And those ingredients are minerals.
So what exactly is a mineral? Well, the easiest way to think about it is like nature's Lego block. It's a solid, naturally occurring thing that has a very specific chemical recipe and a perfectly orderly, repeating structure inside. That's what crystalline means. Stuff like quartz or salt or even a diamond, those are all minerals. They're the pure ingredients that get mixed together to make almost every rock on our planet.
And wow, these building blocks can be absolutely stunning. This right here is a tourmaline crystal. Minerals like this often pop up in these little pockets inside bigger rocks, like granite. It's the perfect example of one of those pure ingredients, just waiting to become part of a much bigger recipe.
Now, these minerals don't just hang out by themselves. They get together, they combine in different ways, and they form rocks. And depending on how they form, we can sort them into one of three big families, and each one has its own incredible origin story.
First up, we've got the fiery family, igneous rocks. The name actually comes from the Latin word for fire, which makes total sense. These are the rocks that were once completely molten, either as super hot magma deep underground or as lava flowing out of a volcano. When that liquid rock cools down, it crystallizes and hardens into solid igneous rock.
And this is about as dramatic as rock making gets. You've got an explosive eruption blasting lava and ash high into the air, where it cools down, boom, almost instantly. And that super fast cooling, that's a huge clue in the story this new rock is going to tell.
See, here's where it gets really cool. You can basically play detective and read a rock's life story just by looking at its texture. If it's got big chunky crystals, that means it cooled down really slowly, probably deep underground. Tiny, fine-grained crystals? That tells you it cooled in a hurry, right at the surface. A mix of big and small? That's called porphyritic, and it tells a two-part story of cooling slow, then fast. And if it looks all bubbly and full of holes, that's a vesicular texture, and it's from gas bubbles that got trapped during the eruption.
Okay, let's move on to our next family. This one isn't born from fire. Nope, it's all about the slow, patient work of water, wind, and just plain old weight. Sedimentary rocks are basically recycled rocks. They're made from little bits and pieces of other things, older rocks, shells, you name it, that all got broken down, moved around, and then glued back together again. The whole process is kind of like making a giant planet-sized layer cake. First, a layer of sediment gets put down, then, over millions of years, more and more layers get piled on top. All that weight buries the bottom layers and compacts them, squeezing all the air and water out. And for the final touch, minerals in the groundwater act like a natural cement, gluing all those little grains together into solid rock.
And this is where it all begins. This loose stuff, sand, pebbles, all kinds of debris, this is the raw material. Honestly, every handful of sand you pick up on a beach or in a river is just sedimentary rock waiting to happen. All it needs is a few million years. Our third and final family is the family of transformation, metamorphic rock. These are the shapeshifters of the rock world. They start out as something else, either igneous or sedimentary, and then they get put under such intense heat and pressure that they completely change, or metamorphose, into a brand new type of rock. And here's the key: it happens without them ever actually melting. A perfect example of this incredible power is what happens to a really common sedimentary rock like sandstone. Imagine it gets buried deep in the earth and subjected to some serious heat and pressure. And poof, its individual sand grains actually fuse together and recrystallize into this incredibly hard, super durable rock we call quartzite. The same thing happens with limestone. You cook it, you squeeze it, and it transforms into elegant marble. It's a total high-pressure makeover happening deep inside the Earth's crust. So, we have our three families: igneous, sedimentary, and metamorphic. But here's the most beautiful part of this whole thing. They aren't totally separate. They're all connected in this huge, continuous process we call the rock cycle. It's basically Earth's ultimate recycling system.
This is it, the whole shebang. And the most important thing to get here is that any rock can become any other kind of rock. There are no dead ends. An igneous rock can be worn down into sand and become a sedimentary rock. That sedimentary rock can get buried and cooked into a metamorphic rock. And that metamorphic rock can get pushed so deep that it melts back into magma, starting the whole cycle over again as a new igneous rock. It's a never-ending story of creation and transformation.
So why does all this matter to you? Because now you've got the secret decoder ring. Armed with what you know about minerals, the rock families, and the rock cycle, you have the key to unlock the history that's hidden in every single landscape. You can actually start to read the story in the stone.
Take a look at this scene. Before today, you might have just said, oh, a hill with a bunch of boulders. But now, you see more, don't you? You might guess these are granitic rocks, which means they're igneous. They must have cooled slowly way underground. So the fact that they're sitting here on the surface tells you there has been some incredible uplift and a ton of erosion over a long, long time. See? You're already reading the story.
So the next time you're outside, here's your new checklist. Keep your eyes peeled. Do you see layers? That's a dead giveaway for sedimentary rock. See a bunch of cracks and fractures? That tells you a story of immense stress. Are the corners rounded and smooth? That's a clue about how long that rock has been out in the weather. The different colors, the loose bits of rock on the ground, it's all part of the narrative.
So if you take one thing away from this, let it be this. Geology is not static. The Earth is a dynamic, constantly changing system. The rock you see today, that mountain, that cliff, that little pebble in your hand, it's just a single frame in an epic movie that's billions of years long. Which leaves us with one final fascinating thought. What's going to happen to it next? What story will that same rock tell a million years from now?